Hey guys, GM. Uh, so today is Jan 1st, 2026. So I wish you all a happy New Year, and I wish you all great success uh, in the year of 26. And since in the last couple of videos we looked at how Morpho and Sablier works, so I always inspired the work from for Solady, since it is the and by the way, it is I think par fast the most difficult code base that we will be reviewing. Reason being is that most of the code is like solo level language, like based on YUL. Uh, that uh, to be honest, I'm quite afraid that of looking into it because it's going to be super difficult, and due to my lack of any experience in knowing assembly, I think this is gonna be cumbersome. But yeah, let's give it our best shot and try to understand the best of our abilities, right? So let's start with it. So first of all, to understand Solidity, it's like helper functions or like helper contracts for a lot of variety of tasks, right? And they are like gas optimized. So their objective is to create technologies which are gas efficient, and they have so many things here. uh, I don't think so that we are going to go in all of them, but we'll do our best, looking at what seems to be interesting for us. So let's start with the 7702 proxy. So for those of you who doesn't know what proxy is a layer between the user and the end contract that is being executed. It stands in the middle, so that by default contracts are immutable, which means that they are not able to change the code, right? And maybe in the future that we want some new features or code to be added into our contracts. uh, so you want a way to like upgrade the logics, right? So we implement proxy, which, just to sum up, is like basically uh, it's like a contract that holds an address for the current implementation, and you can update the value to point it to somewhere else. Like for example, if you want to update a contract with some new features, you can just redirect update the contract address in the proxy, so the delegate calls will be redirected to the new implementations. That's simply it that you need to understand for now. And this is a proxy which will hold the current implementation and will redirect, right? So uh, let's start with it. So it's a EIP 7702 proxy. So let's just understand what is EIP 7702, right? So there are like two types of accounts. First is EOA, which is the general wallet that you use that has a private key, and you can just use the private key to send transactions, sign data, right? And there are like smart contract which holds the logics, but you don't have access to the private key. However, you can upgrade them or like have a code run through them, right? So prior to EIP 7702, there was ways where you can actually make your EOA execute some code. I forgot the EIP for that, but it wasn't as flexible as 7702. So the general idea is that you make your EOA run some code. So it's not just smart contract that are now capable of executing code, but rather it is also EOAs that can run code for a duration of time. So all you need to understand before getting into this contract is that 7702, there is a transaction type. I think transaction type 4 it is called, or whatever. We can just go back and look. It's not necessary as of now. Which adds an instruction where you have like a authorization list where you define which contracts are authorized for your EOA to point at, and you need to pass on your nonce, your address, and your signature to that authorization list, which consists of course the authorized address, and you send it, and it'll stay in the code for your EOA that you have authorized this so and so forth contract as your delegation, right? And whenever you want to remove a delegation, you just null it, right? Just pass on 0 value, so it just resets it. Yeah, so that is like EIP 7702 in general. So let's start with this, right? So let me just go back and let's just remove let's just, how does EIP gets it's different. Can I? Oh, you can't. Code of the EOA for the duration of a single transaction. A chain ID you pass, the address, the non address is the one you are dedicating to. Yeah, so it passes a delegation indicator that this is a transaction, like it's basically authorizing. Yeah. The transaction. Okay, got it. So let's stay to our objective of reviewing the source code here. Let me just check if I'm still showing. Yes. Okay. So first of all, this contract is helpful for us to change the address of the logic rather than like authorizing delegation again and again. So the workflow is the EOA calls. Oh, sorry, the EOA points to AP7702 proxy, which relays to the actual implementation. The relay proxy also allows for reader. Oh, okay, that's cool. For differentiating calls on the EOA and calls on the proxy. So when we are called like delegates, like delegate call does holds the property. I forgot when delegate call to contract B from A will take the message. I mean, I forgot. I think my best guess is that delegate will keep while S call will not. Oh, okay. The message sender. Okay. Uh, I'm taking a short break. I'll come back in like 2 minutes. Yep, sorry about that. So we are back. Yep. So yeah, so what I was reading last time when I was on streaming before going on the break was that when you're calling a contract B from A using delegate, right? So the message sender remains the EOA that initiated the call, and also the message dot value remain persistent. When you're calling a contract B, we're using the call. It becomes contract A becomes the message dot sender, and the value that is being passed from contract A to B becomes the message dot value. Yeah. So moving ahead, for differentiating calls on the EOA and calls, differentiating calls on the EOA proxy itself. How would you do so? Start proxy to be explain. Yeah, I used to create a lot. It's a sender used to. Okay, EOAs have the user who initialize the transaction and message sender keeps message sender. So as far I can understand is EOA से आने वाली call message sender. Okay. Okay. So so whenever we are calling the proxy, right? Uh, the the message dot sender will be the EOA itself, and we are using this to distinguish between what is actually coming from the EOA and versus calls on the proxy. Set if the default implementation provided for optimization. So if the initial admin is equal to address 0, and initial implementation if the admin is 0 and initial implementation is not 0, then we will set default implementation. But if there is like an implementation already provided on Y, okay, never mind. So ERC 1967 basically is an EIP which states that a specific location for storing the implementation contract address, right? So we are computing the implementation slot, which is this, based on the check hash of this string -1. And what is this? This is the implementation slot. Okay, and the admin slot is the same, computed using the same thing, but the only thing is the keyword admin versus the implementation -1. Okay, the transient storage slot for requesting the proxy for for requesting the proxy to initiate for request. Initialization that requires. So it is like some kind of initial request that like we are calling initialization, and this is some data. I'm not sure what it is, but we'll get back to it later. And then we have a constructor which is taking initial implementation. So default implement. Okay, that was default implementation. So if the initial implementation is not 0, okay, assembly. So what we are doing is that we have this constructor which is taking two addresses, initial implementation and the initial admin, and we are making it payable, right? So we need to send some money. Mm-hmm. And then what we are doing is that we have this local variable called default implementation, and then we are storing this initial implementation that user passes to this slot, and same to this, and then we are calling default implementation to, sorry, we are not calling it, but we are verifying whether first of all, I suck at bitwise understanding, like bitwise operations. So this does not make sense to me. It was really hard for me to understand. So basically, it just checks whether these variables are 0 or not, and then it just saves in default implementation. So we don't really need to understand this right now, but just take a note of it that we're just verifying whether the values are zeros or not, right? And then we have a fallback function. So fallback function, just to let you know who don't know, is that when we are calling a function which does not exist in a contract, we then switch back to the fallback function, uh, so whenever we are calling the proxy contract and using a function which does not even exist, right? So it will call the fallback function, and here we are not taking any inputs, and this is we have marked virtuals. uh, uh, I don't know why we have marked it virtual. I think for overriding you need to actually mark override as well, or, no, or not. I'm not sure. I think we can override this. So we are storing self, which is the address of our the proxy itself. The address of the proxy, and then we are calling default implementation, which is the address of the implementation. And we are then loading up implementation slot, which is the address of the implementation itself. Wait a second, but then if we are storing the default, wait a second, it's not, oh sorry, my bad. Default implementation is not an address. Oh sorry, it's initial implementation and this is default implementation. So we are writing to okay, we are writing the results of so okay, so default implementation is 1 or 0, true or false basically, and but actually we are saving the implementation address to implementation address initial implementation and initial admin, and we are doing this. Default implementation, we are just taking the default. I don't understand. I don't understand the usage of this. So okay, implementation slot, and we mask it. Okay, so as I mentioned earlier that I don't really understand the bitwise operation very clearly, right? So so I actually spent some time yesterday reviewing how does these bitwise operation works, but I do not understand, since of course yesterday was a hectic day because of the continuous celebrations. So let's do it today. I think the today's stream will be quite a bit longer than usual. Reason being is that I just want to understand it very much, and I'm very curious to understand this, right? So let's understand. So I'll just instruct that I don't know anything about bitwise. I suck at maths, and it helps me understand how. So I'll instruct LLM in a way that okay, I don't know much about the zeros and ones, the memory and at all. So explain in a way that I understand, right? So just give me a second. Okay, so let me see one thing. Yep. So I'm fetching just give me a moment. Yep. Yep, so we are back now. So guys, what I did is basically so there's one thing in ChatGPT called study prompt. So I have copied the study prompt itself, and I want to understand bitwise operation, right? My objective is to understand bitwise operations throughout the contract of EIP since 2, but I want to give you part for context. I don't understand. Yeah, so I actually what I did was I just gave uh, a chat GPT the prompt for study mode. For those who are interested in getting this prompt, just leave a comment and I can drop it for you guys somewhere. Yeah. Subject pointers to points. Take the quality and invert all the bits lower and disable. The decimal 100.